How do you look at all?
All right, so let's get started. Do you still remember the 4 phases in unified process? Unified process is acronym as UP, right? So what are the major 4 phases in unified process? So which language is widely used in UP process? Modeling language, the UML, right? Unified modeling language. And the 4 phases are inception, elaboration, construction, and transition. So basically, inception is corresponding to the communication planning process activities, and the elaboration also has a portion of planning and modeling, and construction is identical to the construction activity, and the transition has part of the construction and the deployment. So basically, this is the idea. And today, we are going to study a very important topic, which is agile development. So in 2001, come back. So now we see this guy, the name of this guy appeared. So in 2001, come back, and 16 other noted software developers, writers, and consultants made an Agile software development manifesto. So the manifesto for Agile software development, and these guys are called Agile Alliance. So this is a historic moment in software engineering. So this idea, so this is the manifesto. So we are uncovering better ways of developing software by doing it and helping others do it. So through this work, we have come to value these things. So individuals and the interactions over processes and tools, working software over comprehensive documentation, customer collaboration over contract negotiation, responding to change over following a plan. That is, while there's a value in the items on the right, we value the items on the left more. So this is the manifesto for Agile software development. So it's kind of confusing, what is right, what is left. So now let's visualize this process. So basically, in Agile development, we favor individuals and interactions over process and tools. Working software over comprehensive documentation. Then customer collaboration over contract negotiation, and responding to change over following a plan. So this is what the manifesto said. So also values exist on the right, but the alliance, Agile Alliance, favors items on the left even more. So this is the idea. Okay, then the question is, does Agile development actually abandon the software engineering values?
No.
Not at all, right? So in this lecture, we will study what is agility, why it is important. So what are the agility principles? And what is the philosophy? And what, more importantly, what are the requirements for you guys? So are you a qualified developer to use Agile development? So we shouldn't use it as an excuse for not writing documents. So that's not the idea. Okay. So what is agility? So agility means the effective. So when we talk about effective, actually it means 2 things. That is rapid and adaptive. So agility refers to effective response to change. So changes are welcome. And effective, now we see effective again. The effective communication among all stakeholders. and join customer onto the team. So now customer is a part of the team. So this is another difference in agile software development, and organizing a team so that it is in control of the work performed. Now the question is, so why agility is so important? Nowadays, agile development is very popular in industry, right?
The business doesn't care about whether or not you made a plan about software or not.
Okay.
If something changes, it changes. And so you need to be able to adapt to it.
And you'll get fast versions of the software out.
That too.
Okay, very good. Yeah. So the idea is just as you mentioned, the business doesn't respect too much about your plan, right? So as long as their requirements are satisfied, so they don't care how you get it done. So it means that the modern business environment is fast-paced and ever-changing, right? So then in order to keep up with the pace, then agility is very important. So the effective response to change, effective communication among stakeholders, joining customer onto the team and organizing the team so that it is in control of the work performed. Then the outcome is very good. So just as you mentioned, the outcome is rapid incremental delivery of software. Now let's see the two adjective words. So rapid and incremental. It means that we don't try to deliver this software system once for all, right? So we deliver it gradually. Then each increment should be delivered rapidly. So this is the idea. Okay. So as software developers, we really hate changes, right? So when we have made plans, when changes happen, we have to do a lot of work. So a change means cost. So this is the curve for the development cost and the development schedule progresses. So along the x-axis, so this is development schedule progress, and this is the development cost. You see the traditional. So this is conventional software processes. So the cost of the change increases non-linearly, right? So it is kind of exponential, non-linearly as your project progresses. And you see, it is relatively cheaper to accommodate a change in early phase of software development. So why it is the case?
You haven't built most of your source code yet.
Yeah, because we haven't built our source code yet, right? So it's always accommodate a change in early phase, but it becomes more and more expensive as time goes on, right? So the proponents for agile software development claims that this is the idealized cost of change using agile process. So they argue that if we design agile process well, then we can even flatten the curve. So it means that we can accommodate a change later in the development process without making significant impacts on the time and the budget. So this is the idealized. This is the idealized curve. But what about the actual cost of change? So the actual cost of change is this one. It is still much better than the conventional processes, but it is not as expected by the idealized cost of change. So what is the reason? So why it is not flattened as expected?
People are going to create a perfect plan.
Exactly. We cannot create a perfect plan. So this is the idea. Okay. But in this lecture, we will study some agile techniques such as peer programming or continuous unit testing, so that the cost of change can be controlled and reduced. Okay. Then when we use agile software development, we welcome change, right? But then we will have to deal with unpredictability. So in your opinion, what things that may not be predicted or they can be hard to predict?
Just in general, like I would say like a GUI.
Okay, good. Yes, the customers may change their mind. Yeah, very good. Then what else?
Functionality.
Functionality, yeah, that's the common area. So actually, sometimes customers may not know exactly what they want. So as time goes on, they will definitely change their mind. Okay, so in summary, these are the part of the requirements, right? So it's really difficult to predict in advance which software requirements will persist and which will change. So if we can predict, then we can make perfect requirements, right? So it's really hard to predict which requirements will remain the same and which will be changed. So, and it is really difficult to predict how customer priorities will change as the project proceeds. Then in the future, you may find that if their manager is changed, the priorities are also changed. So that depends on your customer. So it is really difficult to predict the requirements. Then also, normally the design and construction are interlinked. It means that when we make a design, we should prove that the models works. So then it is difficult to predict how much design is necessary before construction is used to prove the design. So this is, this depends on your experience. And also analysis, design, construction, and testing are not as predictable as we might like. So these are really difficult. So then the question is, since unpredictability exists, then it will definitely lead. Lead to what? So unpredictability exists, so it will lead to
Added cost and complexity.
yes, added cost and complexity. So that's the results, and also, it will lead to changes. The change will lead to cost and a lot of complexity. So, yeah, very good. So then what is an agile process? So an agile process is driven by customer descriptions of what is required. So in software engineering 1, we call this as scenarios. Okay, so in software engineering 1, when we studied scenarios, we say scenarios are informal, right? Scenarios are informal, and in agile development, sometimes this is called user stories. User story, and so agile process is driven by user stories, informal, because the reason is that the team just wants to save time without building the formal documents, and recognizes that plans are short-lived. Now the question is why plans are short-lived. Then other characteristics like develop software iteratively with a heavy emphasis on construction activities, and delivers multiple software increments that adapts as change occurs. So this is a agile process. So then why we favor short plans and multiple increments.
Like why both at the same time, or?
Actually, they occur at the same time. So the plan is pretty short. Then, for example, we don't make a plan for a whole year. At most we just make a plan for at most 3 months.
Well, if you have a short-lived plan, then you have the possibility of finishing it.
Okay. Okay. Yeah. So it's a possibility of finishing a short-lived plan is much likely, right? Okay. Also, we favor deliver multiple software increments. So the whole idea is that unpredictability exists, so it will lead to change. So we should make sure that the agile process is adaptable. The adaptation should keep up with the pace of change. So the idea is we should deliver operational prototype to the customer as early as possible. So we have studied the prototyping, right? So prototyping, the idea is we give the customers something to play with at an early stage. So agile process follows a similar idea. So we give an operational prototype or a portion of the operational system. Then we deliver it very fast. So before the requirements are changed, so we have to deliver something. So this inspires the customers to think about the functionality and the requirements. Then the requirements are refined, and the next increment will be delivered as soon as possible. So the whole idea is to keep pace with change. So the whole idea is to keep pace with changes. Remember that in agile development, we welcome change. Actually, the top priority for an agile process is to satisfy your customer. If you allow your customers to make changes, they will be happy. Okay, now let's revisit the Agile Manifesto. So basically, we value individuals and interactions, and working software, customer collaboration, and responding to change. So all these are the values of Agile process. So actually, the Agile Alliance defines 12 activity principles, just as I mentioned. So our highest priority is to satisfy customer through early and continuous delivery of valuable software. So the construction is very important in agile software development. So don't be surprised. Don't be surprised when somebody says that they want to talk about the design. They may bring a piece of code to you. So the design can be just in the coding level. But the whole idea is to continuously deliver valuable software. So the highest priority is customer satisfaction. Then second is also challenging. So welcome changing requirements, even late in development. So if the team is lack of experience, then this is going to be very difficult. So it doesn't mean that agile process or agile development is good, so that everybody can use it. So you must be competent before you can get involved. So that's the idea. So agile processes harness change for customers' competitive advantage. Okay, then third, deliver working software frequently. So from a couple of weeks to a couple of months, with a preference to shorter time scale. So the shorter is better. So we keep it a fast pace. Then business people and developers must work together daily throughout the project. So now business people are part of the project. If they cannot make such commitment, you better not use the agile software development. And build projects around motivated individuals, give them the environment and support they need, and trust them to get job done. So trust is also very important. And the most efficient and effective method of communication, so within development team, is what? Still the traditional face-to-face communication, conversation. And working software is the primary measure of progress. So you see, in order to measure the progress, we just use the working software. And agile processes promote sustainable development. So the sponsor, developers, and the users should be able to maintain a constant pace indefinitely. So we just keep delivering new increments. Then continuous attention to technical excellence and good design enhances agility. So technical excellence and good design and actually discipline, all these characteristics should be satisfied. And simplicity, so this is interesting. So simplicity, that is the art of maximizing the amount of work not done. So what does that mean?
Oh, like KISS. You keep it super simple, or keep it stupid.
The kid is super simple.
Yeah, don't reinvent the wheel.
Mhm.
So you can do something else instead of reinventing the wheel.
Okay, yeah. So the idea is we try to maximize the amount of work not done. So we don't try to do a lot of things, right? So we do it, we'll deliver the valuable software, but in faster pace. We gradually add more features, not all at the same time. And the best architectures, requirements, and the designs emerge from self-organizing teams. So team is itself very competent. And at regular intervals, the team reflects on how to become more effective and tunes and adjusts its behavior accordingly. So the team will also summarize the experience and try to make the whole process smoothly. Okay, then the 12 agility principles bring out the philosophy of the agile development. So first, encourages customer satisfaction and early incremental delivery of software. Still, customer satisfaction is the top priority. Then, small, highly motivated project teams. So why? We favor small project team. So why don't we have a lot of developers work together?
Too many cooks on the kitchen, people stepping on toes.
Okay, yeah. So, according to some research paper, when the team reaches 100, then it's, the management becomes extremely difficult. So actually, when software company has more than 100 developers, the management itself becomes difficult. So, yeah, so we favor small, highly motivated software teams and informal methods. So why informal methods? We know that informal methods are imprecise. It is not very precise. Then why we still favor informal methods?
Because things are going to change anyway.
Exactly. So we want to save time. So minimum software engineering work products and overall development simplicity. But it doesn't mean that we do not value the importance of formal methods. For example, if you know the formal methods, you have the experience, so you can make your work in good quality. So if you have no knowledge for the formal methods and software engineering principles and the best practices, it's going to be hard. It's going to be hard to produce high quality work. Okay, now we talk about the human factors. So the process, the agile process, the needs of the people and team, not the other way around. So not the people and team moves the process. So then the key traits must exist among people on an agile team, and the team itself is, first of all, competence. So this is very important. I heard many complaints from my former colleagues. So, you know, they just complain that their team members just used agile development as an excuse for not writing any documents. So this is absolutely wrong. You know, people should be competent before they can get involved in the agile process. And the team should have common focus. And collaboration is important. So nowadays, software development is so challenging. People have to collaborate to succeed. And the team should have the decision-making ability. So this is very important. And also, fuzzy problem-solving ability. So why this is important? Why a fuzzy problem can exist? So in software engineering 1, we studied different methods for requirements analysis and gathering, right? So the whole idea is to remove ambiguity. So we want to make it as clear and understand the problem in the same way. But now in agile software development, the fuzzy problems may exist. Now, why this is the case?
You don't want to lose a requirement just because you didn't understand it, I guess.
Yeah, so probably you don't understand it. Yes, then what's the reason?
And ask the user what they meant.
Yeah, so you know, to clarify, definitely we will ask the users. But the fuzzy problems do exist. So the reason is that the agile process focuses on informal methods. So for example, you know, agile process normally starts with user stories. The user gives you stories, then you start to make a plan. It is very likely that you will have a lot of requirements that may be interpreted in different ways. So the communication becomes important, and that's why customer is a part of the team. So you should also have the fuzzy problem-solving ability. So this is important. And the mutual trust and respect and self-organization. So these are the key traits that must exist among people on agile team. Okay, so do you have any questions so far for our discussion? Yes.
So when you're dealing with a client that's not familiar with Agile, and they present an informal problem in some form that doesn't really work with Agile, how do you go about asking the user to rephrase?
Okay, yeah, actually, the customers do not have to be familiar with Agile process, because you know Agile process is used by the team to deliver high quality software in a rapid and incremental way. So you know the customers may not be mature, so that's the question, right? So the customers may not have the experience or maturity for giving you the requirements. This is understandable, but you know that's why we favor the rapid and incremental delivery. So if you can quickly deliver a very simple system operational to your customer, then you know the physical and concrete system will inspire the customer to think about the true requirements and refine the requirements. So this is the whole idea. So we can expect the customers to be mature and very experienced to deal with the all the challenges. But the customers will be part of the team. So if you have questions, then definitely the communication will help resolve the problems. This are very good questions. Actually, in the future, you will definitely encounter such customers. Okay, now let's see extreme programming. So have you ever used extreme programming in your company, in your work? Not really? Yeah, so actually extreme programming is the most widely used agile process in industry. It was proposed by Ken Beck, still that guy, the guy who proposed the manifesto. So extreme programming, in extreme programming, each increment needs to go through planning, design, coding, and the testing. So now let's see the details. So extreme programming is the widely used agile process. So originally proposed by Ken Beck. So in extreme programming planning phase, it begins with the creation of user stories. So we can also call user stories as scenarios, right? So scenarios, user stories. Then the customer assigns a value that is a priority to each story based on the overall business value of the feature of the function. So this is input from your customer. Then the agile team assesses each story and assigns a cost. So each story is assigned a value, which is a priority. Then each team also assigns each story a cost. Then at least 2 members participate in the assessment. Then what's the purpose? Why at least 2 members participated in the assessment?
So you get rid of bias.
Yeah, to get rid of bias. We don't want to make over commitment, right? Then it's measured in terms of development weeks. So we want to keep it short. Now the question is, what if a story is estimated to require a long time, for example, more than 3 development weeks?
Would we break it up into different parts?
Smaller ones, right?
Yeah.
Okay, so that's the whole idea. Then the answer is partially right. So definitely we need to break it down into smaller pieces. But shall the team do it or the customer do it?
The team.
I'd say team.
Okay, so it's who provides the user story?
Well, customer provides the user story, but
So the customer provides the user story, but the story itself is too complicated, which requires a longer time than 3 development weeks. Then normally we ask the customer to split the stories into smaller ones. Then
Would it be possible for the team to split it up into child user stories and send it back to the customer and see?
yes, in order to save time, you can do that, but make sure that the customers approve the change. Otherwise, it's your responsibility. Okay, yeah, so very good. So after the stories are split into small ones, then what's next?
Reassess.
Okay, very good. So we are not done yet. So the idea is after a longer story is split into smaller ones, then customers are required to assign a value still. Then the team assesses each smaller stories and assign a cost. So we repeat the same process. So this is during the planning. Then stories are grouped for a deliverable increment. Then a commitment is made on delivery date. For example, in 3 weeks. Then, you know, now imagine that you are a key member in the Agile team. Now all the stories receive a value and also receive a cost. Then what should you do? You know, how would you order the stories to you know, to make a commitment?
Would you do the higher cost first?
Okay, very good. So you know, we can implement the stories with the highest values or highest cost. Very good. So that's one of the possible ways.
Can you group it by priority as well? Like there's
Yes.
cost and then a priority value.
Yes. Yeah. So we can move the stories with highest priority or cost up to the schedule. That, you know, this is definitely a good way. You know, actually, we should also analyze the actual work to be done. So if we can implement everything within 3 weeks, definitely we implement everything, right? So we put all stories in the delivery. But if it is impossible, then we can move up the stories with the highest cost or highest priority, or with the highest risks. So you know, the most risky stories can be moved up in schedule and implement. So these are different options. So in the future, once you finish the XP planning, you need to make a commitment to your customer. So these are the strategies. If possible, then you definitely put all stories all together, or you order these stories based on priority, cost, or risk. Okay, then extreme programming design. So we follow the KISS simple, so principles. Then the KISS principle means, what does KISS mean?
Keep it simple.
Keep it simple. Yeah, sometimes people also add another S. So let's keep it simple and stupid. So principle. Shortly, we will see an example for the KISS principle. Then we also encourage the use of CRC card. So do you know what does CRC stand for? CRC. So the first C represents class. R represents responsibility. Then the second C represents collaborator. So this is the informal method for the requirements analysis and design. So in chapter 8, we will study the CRC cards. So basically, we follow the KISS rule. We make this very simple, and we use informal method in terms of CRC cards to make the design. Then for difficult design problems, suggest the creation of spec solutions. So what is a spec solution? It is a design prototype. And we also encourage refactoring. So we studied refactoring in software engineering 1. Do you still remember what is refactoring?
Changing the structure or something without changing the purpose of it.
Okay, very good. So that is a refinement of internal program design. So just we need to keep what it does, but the internal structure may be refined. Shortly, we will see another example. Okay, so the spec solution. For the spec solution, the intent is to lower risk when the true implementation starts. So before we fully implement the requirements, we want to build the prototypes to prove the idea. So then also to validate the original estimate for the story contained in the design problem. So in XP design, we follow the key principle and encourage the use of CRC cards, and we may create spec solutions, and we also use the refactoring and coding. So XP coding is the key part, because extreme programming just pushes toward the construction and delivery. So it recommends the construction of unit test before a story, before the coding commences. So we started a term for this. So what is that?
Test-driven development.
Test-driven, right? So this test-driven development. Test-driven development. Before we write code, we write the unit test. And also we encourage peer programming. So this sounds a little weird. In peer programming, two people work together at one computer workstation to create code for a story. It means that one person is responsible for writing the code. The other person oversees the entire process. So the benefit is that this is a mechanism for real-time problem solving and real-time quality assurance. Two minds are better than one. If somebody watches over your shoulder, it's kind of pressure, right? So it's but that's a real-time quality assurance mechanism, and the people will switch the roles from time to time. So it takes different roles. But keep in mind that in extreme programming coding, we favor test-driven development, and we encourage peer programming. And testing is essential. So all unit tests are executed daily, and acceptance tests are defined by customer and executed to assess customer visible functionality. So basically, in extreme programming, we have planning, we have design, coding, and testing. So these are the four phases to make an increment. So do you have any questions for the discussion so far? Okay. Then what is refactoring? Refactoring is very important, and it is important in extreme programming design. The goal is to improve the design of existing code without changing what it does. The functionality is not changed, but we improve the design in terms of maintainability and efficiency. So we will try to make the code easier to change, more loosely coupled. So do you still remember the definition for coupling? Do we favor high coupling or low coupling? Low coupling. So coupling is
one applies to another, such that if you that one depends on another.
okay. So the idea is we favor low coupling. So if we make change to one component and the others do not won't be impacted. So that's a matter of the degree of interconnections among the modules, components in a software system. Then correspondingly, we want to more cohesive modules. So we study cohesion, right? So do we favor high cohesion or low cohesion?
High cohesion.
High cohesion. So that's a measurement of self-containedness of a module component to what degree does it perform a single task. So the idea is refactoring will lower coupling and increase cohesion. So this is the whole idea for refactoring. And it leads to more comprehensible code. So refactoring will bring side effects, right? So for example, your code works pretty well. So for example, your code works pretty well, and part of the requirement is to sort something. So you use the bubble sort. You can hardly make a mistake if you use bubble sort. So it works very well. But now you want to you want to refactor your code, by replace it with the, let's say, quick sort. Okay, then probably such changes will bring side effects. Then what should you do to avoid or reduce the possibility of side effects? Test, very good. And test alone is too general. So actually we favor automated unit tests. So we want to automate this process so that we can make sure that the refactoring doesn't bring unexpected side effects. So this is the whole idea. So agile development assumes that the best designs will evolve and emerge through many iterations. And the refactoring is essential to an agile evolutionary approach to design, because designs need to change as we learn through constant feedback and what works and what doesn't. So the refactoring process. So for the refactoring process, we want to make a small change. So we don't want to make a lot of changes, right? So we just want to make a small change, a single refactoring. Then we run all this first step, make a small change. Then in the second step, we run all the tests to ensure everything still works. So this is called regression testing. Then if everything works, then move on to the next refactoring. Otherwise, we fix the problem or undo the change, so you still have a working system. So is that clear? So do it very cautiously, so carefully. We just do it step by step and make small change and do regression test, make sure that everything is okay. And code smells. So does your code smell? So a code that make design harder to change. So these called code smells. So some examples are. So can you give me some examples for code smells?
High coupling.
High coupling. Yeah, high coupling code. Then what else?
Not using interface.
Not using interface. Okay, just lower abstraction, right? So just rewrite program to the concrete classes. Very good. Yeah. So how about duplicate code? The same code appears in many different places. And then long methods. So long methods can be difficult to maintain. Big classes. So we may have just a few classes. Each class is super big. Then big switch statements. And then long navigations. For example, A.B, the parentheses .C, and so forth. So this is really hard to understand. And too much checking for non-objects and data clumps. So for example, similar to non-normalized tables in relational database and data classes. This, the classes have a lot of fields, properties, but such classes don't have little or even no methods and encapsulated fields with public member variables. Okay, so some of you have already seen this in Software Engineering 1 class, but now let me use the same example to give you an idea for the refactoring, and the test-driven. All right. So remember that I once gave you examples for the calculator. So for the calculator, we provide some, we provide some input as numbers, and then the calculator should do some calculations for us, right? So this is the whole idea. Now I have empty class that's called RPN calculator, so it doesn't have anything. And it doesn't have any operations either. So now I want to implement the functions, for the RPN calculator. So we follow the KISS rule, right? So the KISS principle, we keep it simple. Then first, we don't want to add a lot of functions to the RPN calculator. Let's just provide the very fundamental implement for very fundamental functions. For example, we provide a number, then the calculator should show the same number back, right? So by following the test-driven development, we should write the test before we write any code, right? So before I write any code, let me write the test. So let me write test. So this name of test group. And then let me give it a test case name, initial value. Okay, so you see I have created a pointer, which is called RPN. So then before I assign any value to the calculator, by default, it should show 0. Before we use the calculator, when we turn it on, then the initial value is 0, right? So let me make sure that the initial value is 0. Expected. That's RPN. Okay. Okay, then let me test another function. Test get set. So if I set a value to RPN, then I should get some value back, right? RPN, let's say, set value. Let's say I set 10. Then I should have ones. Okay, so for test driven, let me make it bigger. Sorry. For test driven, before we write any code, we write what? We write the test first, right? Then, do you think that the test will pass? No. It is impossible because I haven't written the code, so it cannot be compiled, right? So now let me try to compile it. So just try to build a solution. You see it failed. No? Okay. What? So then it is even cannot be compiled, right? Then before we write code, we write the test. Now let me make the code work. So we value the simple case root, right? So now let me put current value in integer value. Then define two operations. For example, int you get current value and what is set current value. Let's see the implementation. And we simply return value. And we value set on the value. Okay, so now I have now I have implemented. So now let me try to rebuild the solution. Hopefully it works. Now you see the code is generated. So so let me okay, let's test driven and let me run it. Okay, so now let me show you the idea. In our unit test, I wrote two test cases, right? So the first one is to test the initial value. In the beginning, the calculator should show 0. Then the second is to test getter setter. If we set a value, then we should get the same value back. So now you see, it failed the first one. The exact value is 0, but the return value is something random. Now what's wrong? What's wrong with it? I created an integer value to keep the current value, and this is the code.
Initialize?
Hmm?
You didn't initialize the value?
I didn't initialize it, right? So that's a key point. So here, then I can initialize value to be 0. So now let me rebuild it. Rebuild the solution. Okay. Now let me run it again. You see, both tests succeeded, right? Okay, so it means that before I write code, I write the test first. Then I write the code to make the test pass. But in any meaningful RPM calculator, so RPM calculator means that it is reverse polish. So I hope you still remember the reverse polish. So it means that if we write 5 plus 6 equal 5 plus 6, then actually we should put it like a 5 6 plus, something like this. Now, what is the best data structure for this reverse polish order. In order to implement this. For example, if we I have 5 plus 6 multiply 2, then I can put 2 multiply something like this. Then what's the best data structure for this one? Stack. So that's the stack, right? Okay. Very good. So integer value is not the best solution. So I can define my own stack. Then I can call my stack values. Then I try to use stack to implement this. So to get current value, I can put integer b equal to 0. And if value that is stack empty, then it's not empty. Then value v is equal to value dot top. And we return v, something like this. And for this one, for the stack, set current value, you simply push the value to the stack. And something like this. Now let me rebuild the solution. So now this is kind of code refactoring. So initially I just use a single integer variable to keep the current value. Now I use a stack for all. Okay. Okay, you see, I quickly replaced the integer variable with a stack, right? Now, did you notice that I made any changes to the test cases? I didn't, right? I didn't change any test cases. Now let's see the test driven. You see, both tests pass. So this is the whole idea of the entire test-driven and the continuous unit test, automated unit test idea. So before we write any code, we write the test cases. Then we write code to make the pass. Then when we realize the issues, we start to refactor our code. So then we rerun all the tests to make sure that our code still works. So this is the idea. So is that clear for this process? Okay. So that's all I have today. Do you have any questions? Okay, yeah, all right. So wish you guys have a very wonderful Labor Day. Thanks.